All right, I want us to check this example here. So a car has a momentum of 20,000 kg meters per second. And then the question says, what will be the car's new momentum be if the mass of the car is doubled and it travels at the same velocity? So this question wants you to know and understand the relationship between the quantities on the formula of momentum. So P is equals to mv. Ne? So they want you to know the relationship between these three quantities here. So they've given us only the momentum. They tell us that they double the mass, but the velocity is kept the same. So let's do an example whereby we're having an object, and this object has a mass of 2 kg. And then it's traveling at a velocity of 2 meters per second. And then the momentum of this certain object will be 4 kg meters per second. So what will happen if we double the mass but we keep the velocity constant? So now it means if we double the mass, we're going to have P is equals to mv. Ne? Then when we double the mass, the new mass will be 4 kg. Then we keep the velocity to be 2 meters per second. And then now our new momentum will be 8 kg meters per second. So can you see that when we double the mass, then the momentum also doubles? Because if you can check the two momentums, the momentum before we doubled, it was 4, and then the momentum after we doubled this mass, it was 8. So we can see that it's the same thing as doubling the first momentum. So it means when we double the mass, the momentum will also be doubled. Similarly, if we double the velocity or reduce the velocity by a factor, then the momentum will also be affected in that way. So it means now P is directly proportional to the mass, and P is also directly proportional to the velocity. If we increase either the mass or the velocity, it means the momentum will also increase. But if we decrease either the mass or the velocity, then the momentum will also decrease. So the relationship between these two, or these three quantities, is that the momentum is directly proportional to the two. So in this case, the momentum was 20,000. This was the initial momentum. Then it was 20,000. Okay, so the mass was doubled and then the velocity was kept the same. So if we double the mass, it means our new momentum, which is what the question is looking for, the new momentum. The new momentum will be 40,000 kg meter per second, because if we double the mass and keep the velocity the same, then it means the momentum should also be doubled. I hope it makes sense, everybody. I hope you are not lost. So the second question says, what will be the velocity, or what will be the velocity if the momentum is given and the momentum is 60,000 kg meters per second, and then the mass of the car is what? It's 2,000 kg. So they want the velocity, and then you are given the momentum, then you're also given the mass. So it means now P is equals to mv. So you're given the momentum. Your momentum in this case is 60,000 kg meter per second is equals to, then you're given the mass. The mass is 2000 kg multiplied by, we are looking for the velocity v. Then it means we are going to divide both sides by 2000 kg, and then we also divide this side by 2000 kg. Then we get that our velocity v is equals to, then when we get our calculator, we get that our answer is equals to, velocity is equals to 30 meters per second, because this kg will cancel this kg and then we remain with meters per second. So remember, this is velocity and we are not given a direction, whether the car is traveling in the eastern or the western direction or left or right. So we can say in the same direction as the momentum. So this is 30 meters per second in the same direction as the momentum. Remember, this is a vector quantity, magnitude and direction. So let's look at the third question. It says a truck has a mass of 6,000 kg and it travels 80 kilometers per hour to the left. Then the question says, how does the momentum change if the truck is now loaded with what? 1,200 kg and then it travels 60 kilometers per hour in the same direction. So it means the truck is still going to the left. So it means now we're having situation 1 here. We're having our truck. Okay, so this is our truck. Initially the truck has a mass of 6,000 kg and it's traveling 80 kilometers per hour to the left. Okay, so at the later stage or at the final stage, we have our truck here. Okay, then our mass of the truck now is, the initial mass of the truck was 6,000 kg, and then now they added a load of 1,200 kg. Then the velocity at which the truck now is traveling at is 60 kilometers per hour. Okay, so now the truck is traveling to the left, so it means it's going in that direction. So we can take that direction to be positive. So it means our left is positive. So remember, when we were dealing with the SI units for momentum, we said P is equals to mv, and then the mass should always be given in kg, then the velocity should always be given in meters per second. So now we're given these velocities in kilometers per hour. So it means we must convert the velocity to meters per hour. So we just have to divide this value here by 3.6. Then we also divide this one by 3.6, so that you move from kilometer per hour to meter per second. So when you divide 60 kilometer per hour by 3.6, we get that is 16,67 meters per second. Okay, so this velocity of 80 kilometer per hour, then it becomes 22,22 meters per second. So now our information is complete. We converted this, and then now we know the initial part of this truck, the mass and the velocity in meter per second, also the final position of the truck. Okay, so now the question wants us to calculate the change in momentum of this truck. ne? So to calculate the change in momentum, we know that the formula says change in P is equals to P final minus P initial. Okay, so it means we have the mass, the final mass, and the final velocity minus the initial mass and then V initial. So the final mass, we add the 2 here, then we get that is 7,200. Okay, then we multiply by the velocity, we use the one that we converted, so it means we're going to have 16.67, and then minus the initial mass was 6,000, and then the velocity was 22.22, and then when we press that to the calculator, 7,200 multiplied by 16.2, we get that is 120,024, and then we subtract 133,320. Okay, so the difference here is negative 13296. Okay, so this, remember, this negative shows us the direction, so we took left as negative, as positive, so it means any motion in opposite of left, it will be negative. So it means now your final answer is 13,296 kilometers kg per meter per second, then to the right. Okay, so this is the change in momentum for the truck.